Okay, hello everyone. Let's go ahead and take a look at solving trig equations part 2. And what we're going to do is we're going to take a look at how we can solve yet more difficult trig equations. So here's a problem for you. Let's say, for example, we have 2 sine x plus cosecant of x is equal to 3 sine squared x plus 3 cosine squared x. Wow! How in the world are we actually going to go ahead and solve this type of complicated looking problem? Well, there are a couple of keys that you want to keep in mind, and if you can remember these things, then usually solving something that is complicated looking as that can be rather simple because you break it up into smaller steps. Okay, let's take a look at some of those keys. Now the goal, let's say for example that if we wanted to go ahead and solve this, being that we know that this is an equation, is that we want to go ahead and kind of think about them as factors almost, and we want to go ahead and take a look at, can we actually get one trig function per factor? So in other words, if we go ahead and say we can factor it, then if we have one trig function per factor, then usually that's going to be something that will be manageable for us, because then we can break it down even further using the zero product property to go ahead and deal with each one of those factors separately. So let's go ahead and take a look at what we can do in order to get to that goal of having one trig function per factor. Okay. Now, one of the things that we can do is we want to also go ahead and take a look at trying to get the same trig function. Like, take a look at this. We have sine x, cosine x, sine squared x, cosine squared x. We have 3 basic trig functions. The sine squared, of course, and the cosine there are both squared, so it's really 4 different types of functions that we have to deal with here. The thing is can we get it so that it's all the same trig function? Okay. The other thing that we want to do is we want to make sure that all of them have the same argument. Now, when I talk about the argument, it's this. It's x. It's x. It's x. It's x. If this was sine of 2x, then of course that would be a different argument from the cosecant of x. So we want to try to make sure that we have the same argument as well, and in this case we're lucky enough to know that all of them are the same. Now we also want to go ahead and take a look at factorization, because of course when we go ahead and take a look at anything that's a quadratic or anything even higher in terms of a polynomial, then we want to go ahead and always use factorization and the zero product property to go ahead and solve for the particular values of our variable. Now, we also want to go ahead and recognize identities, because remember that sometimes identities, either you're going to make it more complicated for a particular purpose, or you're going to try to make things more simple, because of course identities mean that they're equivalent. So let's go ahead and try to use some of these goals here, to use some of these methods here to get to the particular goal of getting one trig function per factor. Okay, now when we go ahead and take a look at this here, hopefully everybody recognizes that there's a very, very obvious one that's right here, a trig identity that can simplify this problem right here. Okay, so if we go to sine x plus the cosecant of x, this is 3 times by the sine squared of x plus the cosine squared of x. Isn't that nice that we can now go ahead and just write that as 1? Okay, so notice what happens then is by using my trig identity, I've actually simplified this equation to something that's much, much more manageable. Okay, now we use one of those trig identities, right? We recognize that we used it, we simplified the right-hand side of the equation. Now let's go ahead and take a look at the same trig function, because we still haven't resolved that issue with the cosecant. And remember, we said that everything is based upon sine and cosine. So let's go ahead and change this so that it's in terms of sine. So we go 2 sine of x plus, this is 1 over the sine of x is equal to 3. Okay, now how do we go about doing this now? Well, I don't like to deal with fractions very much. Let's go ahead and multiply everything, both the left and the right hand side, by the sine of x. Okay, and if we do this, we come up with 2 sine squared x plus 1 is equal to 3 sine of x. Okay, now how did that help us? Now, one of the things that we need to go ahead and recognize as well is that we have one of the sine x's being squared, one that's a linear term and a constant term. We have a quadratic term, a linear term, and a constant term. That's a quadratic. So what we want to do now is let's go ahead and put it into a more familiar form that we're used to seeing. And this would be 2 sine squared x minus 3 sine x plus 1 is equal to 0. That's a quadratic. There you go. It's just that there's now sine x instead of, say, for example, just x. Can we factor that? Okay, because remember, again, the thing that we want to try to get to is one trig function per factor. We have one trig function here. Of course, this one is squared. But if we factor it, then everything should just be one trig function per factor. So what we have then is 2 sine of x. We know that this is also going to be sine of x. This has to be equal to 0. And then we know for a fact that this has to be a plus 1, so this is a minus 3 as well, so that has to be a minus 1 and a minus 1. Okay, so what we come out with then is we come out with 2 sine of x minus 1 is equal to 0, or we have the sine of x minus 1 is equal to 0. There's our zero product property. And now we can actually go ahead and solve for the sine of x, which in this case is 1/2, or the sine of x, which is equal to 1. So notice that what's happened now is we're not going to go any further than this because all of you know how to actually determine what the values of x that we're looking for, is taking a look at what we have here as a very, very complicated looking problem, a trigonometric equation. We're going to be using the same, we're going to try to aim for one trig function per factor, and in order to do that we need to use the same trig function. We have to try to get the same trig function, the same argument, factorized, and also recognize where we can simplify the equation by using our identities. Okay, and so there you go. That's all what you need to do in terms of actually solving this particular problem. Now, of course, we're going to come across other problems which might have certain other circumstances, but I think in general, if we can kind of look at these and remember some of these things, in particular what the goal is and how we need to get to the goal, then solving these equations is a matter of practice and also a matter of being able to see how we can go ahead and solve using different methods. Okay, so we'll go ahead and practice these in class and we'll see how everything goes. Again, hopefully these goals as well as the keys to get to the goal will help you solve these more difficult trig equations. Okay, see you next time. Bye.